So in past videos, we've talked a lot about circles and angles. In this video, we're going to focus on circles and different segment lengths. So remember, there are a lot of different types of segments in a circle. You've got chords, which go from across the circle, just from a point on the circle to another point on the circle. You've got secants. Secants like cut through the circle in some way, but they might continue outside. And then tangents are lines that literally just touch the circle at exactly one point. So we're going to talk about the lengths of some of these different segments today. All right. We're going to start with two very common sense ones, but I just want to go over these briefly. Let's say you've got chord AB and chord CD, and you can see by these markings that they are congruent. What do you think we could possibly say about their arcs? So you may have guessed it, but if the chords are congruent, then their intercepted arcs are congruent. It's that simple. So like if these two chords are the same, then the two arcs are going to have the same length as well. Or if these two chords are the same, then these will also be the same length. So that's it on that one. So for example, let's say segment PR is 12 inches, segment PQ is 12 inches, know that those are congruent, and arc PR, right here, is 14 inches. What would be arc PQ? It would just be the same, also 14 inches. That's it. All right, let's talk about another kind of common sense one. Tangent segments that are drawn from the same point are congruent. Again, this is kind of it's pretty clear when you draw it out. Like if I draw a tangent line this way versus drawing a tangent line this way, those two tangents are always congruent. I like to think of this as a little birthday hat theorem. If you make a birthday hat out of it, it's going to be even. You don't want a floppy birthday hat. So those two tangent lines are always congruent. For example, let's assume these are tangent lines here, that I know that those are tangent lines. If that's the case and they're coming from the same point, then I know they're equal. So those two should equal each other. So let's just solve that. 7x minus 2 should equal 3x plus 8. So to solve for x, just subtract 3x from both sides. So you get 4x minus 2 equals 8. Then add 2 to both sides. So 4x equals 10. And divide by 4. So x equals 10 fourths, or 5 halves, or 2.5. All right, let's talk about chords a little bit. This is not as intuitive. So with chords, remember chords cut across the circle. It's actually a really cool relationship. These chords, wherever they cut each other, form these kind of proportional pieces. If you multiply the two blue pieces together here, you get the exact same thing as if you multiply the two red ones. A times B equals C times D, which is kind of cool. So let me show you an example of this. Let's say I want to find T here. I know that 12 times T equals 10 times this. I'm going to have to do a little algebra here, but I know that these two pieces multiplied equals these two pieces multiplied. I'm going to go ahead and distribute the 10. So I've got 12t equals 10t plus 60. Subtract 10t from both sides. So 2t equals 60, then divide by 2. And so t is 30. If you wanted to check and make sure, put in 30 for t. Does 12 times 30 equal 10 times 36 if I put in 30 here? And it should. They should both give you 360. All right, let's try one more of these. I want to find the length of segment AB. To be clear, I already know this is 8. So all I really need to find is this piece. I'm going to call that x. I know there's already an x here, but I'm going to call that x just because it's missing. And so I know 8 times x equals 10 times 10, which is 100. And so then to solve for x, just divide by 8, and there you have it. What decimal is that? Let me find my calculator. 100 divided by 8 is 12.5. So that's what this length is right here. Again, that's not the answer. It asks for AB, which is this whole thing. So if you go 8 and then another 12.5, just add them up and you would get 20.5. All right, this changes slightly if you're talking about secant lines rather than just chords. So basically, if it goes outside the circle, it's similar, but it's slightly different. This also works with secant tangent angles. So basically, the way I remember this is the outside multiplied by the whole equals this outside times the whole. So they kind of have that written out here. I don't know if that confuses you or not, but basically A times A plus B, the whole thing, is going to equal C times C plus D. So like the part times the whole equals part times the whole. Or the whole times the external equals whole times external. So let me show you a couple examples of this. All right, I want to find x, and so I know the outer times the whole thing equals this one's outer times the whole thing. So the outer is 16 times the whole length of this segment is 16 plus another 24, which would be, add them up and you get 30, 40. That should equal this one's outer, 18, times the whole segment, but I don't know what x is, so the whole segment here is going to be 18 plus another x. So I'm going to do 18 plus x. All right, now that I've got it all set up, I can just solve for x. So 16 times 40 would be 640. You could divide by 18 if you want, or distribute it. I'm going to just distribute it. So I get 324 plus 18x, and then subtract 324 from both sides. So 640 minus 324 is 316, and then divide by 18, which gives you 17.5 repeating. All right, let's try another one. This one is, oh, hold on. This one is it's not two secant lines, it's actually a secant and a tangent, but the same principle as before applies. So you still do the outer times the whole equals the outer times the whole. It's just that on this tangent line, the outer and the whole are the same thing. So let's do this. The outer is x times the whole. The whole segment here would be x plus 5. On the top, the outer is 6 and the whole is 6. So we'll just do 6 times 6. That actually gives me a quadratic equation, x squared plus 5x equals 36. And we're going to have to solve this quadratic. So x squared plus 5x minus 36 equals 0. I'm going to try to factor it. So like what multiplies to give you 36 and adds to give you 5? Should have done this beforehand. That would be 9, I think, right? Yeah, 9 and 4. So x plus 9 and x minus 4 would be the factored version. And then to solve it, you set these equal to 0 and solve. So this one's going to give you negative 9 and this one gives you positive 4. Obviously this length can't be negative 9, so we're going to go with the positive one, 4. Let's check and make sure that worked. If I do outer times the whole So if I do 4 times, the whole thing would be 9. Does that actually equal 6 times 6? And it does. All right, let's try one more. And this one, again, it's a secant and a tangent line, but we'll still just do outer times the whole. So the outer is 7, the whole is 16, if you add up these two. For this one, again, the outer and the whole are the same thing. The outer is x and the whole is x, so we'll just do x times x, which is x squared. And 7 times 16 is 112. Again, this is quadratic, but this one isn't that hard to solve. Just square root both sides. You don't need the negative version because the length can't be negative. So square root of 112, or if you want to get a decimal, it's about 10.58. Will be this right here. All right, just to sum all that up. Again, if it's 2 chords, all you have to do is multiply these 2 pieces together, and that equals these 2 pieces multiplied together. But if it ever goes outside the circle, you have to do outer times the whole equals outer times the whole. And if you've got a tangent line, the outer and the whole are going to end up being the same thing. So it usually just ends up being that tangent squared. All right.